So first of all, I would like to thank you for the opportunity to share this presentation with you, in which I will show the problems we were solved together with installers and investors. Importantly, the solutions I'll be showing are real-world examples of our energy storage implementations. The current challenges facing the energy sector includes the variable energy price, which create opportunities for savings, especially during morning or evening price peaks, power outage and power quality, which cause incomparable losses. Customers in larger cities can often sleep and outside the agglomeration, it's a big problem. It's outages where our solution can help. And the addition fees, such as capacity fees, which DSO punishes the customers for non-balanced consumptions during the day or at night, and power quality is also related to that. And the photovoltaic energy prices, which are resold at record low prices. At KSTAR, we solve these problems. We only provide this opportunity and support. So let's jump to our solutions. The new version of our hybrid inverter with an all-in-one solution of this energy storage system. We have the 125 DP2 hybrid inverter, which is the bigger, and the smaller one, which is KSC 50 DP2. This is 50 kilowatt nominal power and 125 kilowatt nominal power. And we can see here the possibilities of the DP2 can achieve from 20 to 50 kilowatts, and the KSC 125 can be from 80 to 125 kilowatts. And the inverters are always on the side, mounted on the side of the cabinets. The battery cabinets can be the 233, which means that 233 kilowatt hour is the capacity, or 107 kilowatt hour, or 187 kilowatt hour. And these also can be changed by 70, 89, or 215 kilowatt hour. Some features of the new generation KSC inverters has a built-in switching device inside, which can change the operating mode from on-grid to the off-grid without any impracticable to the most of the devices. And it has the integrated input of the DG generator that can start according to the SOC levels of the battery cabinets. And the next feature is the unbalanced output of the hybrid inverters. It has the limitation of 100% output in unbalanced mode, but maximum 50% of the rated power for one phase. There is no need for external isolation transformer on the load side to install, because it solves the smooth switchover from on-grid mode to off-grid mode. And we have the limitation is that we can use only 6 units in off-grid mode, and we can use the 20 units in parallel in the on-grid mode. So this is the all-in-one solution. We see the EMS screen on the middle, which is a EMS LCD screen. This is the heart of the equipment. So it can be, the first commissioning are done by here. So there is a efficient air conditioner on the door, which is automatically heating or cooling the batteries inside according to the temperature, but it's measured. And we can see on the next page, when we open the door, there is a BMS communication terminal, the high voltage box for the protections of the AC and DC side, and of course the battery modules, which are in the column on the middle. So first I would like to show some of the cases. This single system in the Opole voivodeship is the first implementation using a new generation inverter. The installation is connected to the local power grid, ensuring the auto consumption, self-consumption, lowering of the mechanical plant. I will talk later about all of the working modes which is possible with our equipment. Currently, the system is operating smoothly, and investors is not concerned about the temporary disconnections. The previous system had an emergency output of 50 kilowatt. However, this is not the maximum we can offer, because new generation KSTAR inverter can be connected in parallel up to 6 units, and this is only one. And the system is AC coupled without photovoltaic panels. Okay, the next is a bakery and load voivodeship. Decided to provide emergency supply for the entire plant, where the nominal load is about 300 kilowatts. Our approximately 500 kilowatt system can support the entire plant, supported by a diesel generator in off-grid mode. Next is in Bulgaria. It has also the auto consumption mode. It has an emergency supply, which is only working after the grid has a blackout. The batteries automatically start to discharge the remaining SOC, the remaining power that we set in the minimum SOC setting. In Slovenia, in Prekmur, there is an on-grid plant which is connected to the virtual power plant, and this VPP integration makes it possible to let the charge and discharge of these equipments incorporate with the DSO. So it's like trading purposes of the system. And next is in a hotel in Romania. It also helps the auto consumption of the household. It has a parallel working of the equipments together, and it has DC coupled solution, which means that the panels, photovoltaic panels, are connected to it. We have in one project in Estonia. It's an AC coupled system right now, and it works with the old generation inverter, because it can be also applied for a off-grid system. In case if we use a STS device, I will show it later. This is a standalone cabinet in the middle, which makes possible the switch over from on-grid to off-grid. And we have one project in Lithuania, and this is a simple one single cabinet with solar extension, and it's mostly working in on-grid mode. The portfolio of our system, what I mentioned, there are different versions of the nominal power of these hybrid inverters and different capacity for the storages. In our system, for the 280 ampere hour cell, we are using CATL cells, and for the 314 ampere hour cells, we use the EV type manufacturer. Regarding the safety features of this cabinet, we have a safety valve on the top, the CO sensor inside, the smoke detector is inside, the fire extinguisher connection is it's on the bottom. There is anti-explosion flap on the top, visual and acoustic alarm in the system, and the fire extinguishing aerosol inside the battery cabinets. We have it in the battery level, this fire extinguishing aerosol, and in the battery level also we have this extinguishing aerosol. This working like displacing the oxygen inside the cabinet, which is preventing the fire to occur. So it has a really fast warning system. The system reacts at 180 Celsius degrees, and the lithium iron phosphate thermal runaway is about 800 Celsius degrees. So it has much time to react. I show the possible applications regarding these solutions. So let's talk about first the on-grid solution. We can use parallel maximum 20 pieces of these equipments. Each of them has a battery and a hybrid inverter, which can be PV connected into it. And this can go up to 20 pieces. And each of them should be connected to this EMS01D KSTAR industrial controlling box, which will make possible to work in one system, all the equipments. And this is for the on-grid solution. Regarding the possibility of the network is 4G Wi-Fi or Cat6 UTP cable can be connected to it to reach the internet, and each of the cabinets can be connected by TCP to this equipment. And there is a possibility to integrate to the existing system where is already PV installed. And in that case, the measurement also needs to be connected to the EMS01D. And regarding the on and off-grid solutions, we have the new inverters, and it can have the dedicated diesel generator input, the dedicated backup load input, and the normal input output. This has a limitation to maximum 6 pieces of this 50 kilowatt inverter or 125 kilowatt inverters. The maximum is 6 pieces. And we can see here the available solutions, which battery cabinet can be connected to which type of hybrid inverter. So if we're using the small ones, we can connect up to 127 kilowatt hour cell battery cabinet, and if we are using the 125 DP2 or the KSC 100 DP2, this is 125 kilowatt. We can use the bigger cabinets, which is 215 or 233 kilowatt hours. If we are using the 197 we have a possibility to double the inverter on the right and the left side, which will increase the nominal power of the charging and discharging power. For the on-grid solution, if we are putting together 20 pieces, we can reach up to 4.28 megawatt hour for the capacity. This is the biggest, and in that case, we can double the battery cabinets also with one inverter. In that case, one inverter connects to two battery cabinets, which doubles the capacity of the possible system. And also for the KSC 125 on-grid solution, we can use 10 pieces for this bigger one together. All of the equipment should use this EMS01D industrial control box that I mentioned before. The on-grid and off-grid scaling is what I mentioned, the 6 pieces of KSC 50DP2, which can achieve the 300 kilowatt nominal power, and the maximum doubled capacity of the cabinets can reach the 2.364 megawatt hour in case of using the 187 kilowatt hour system. And for the KSC 125 DP2, we can also use the 6 pieces for the inverter, which can achieve the 750 kilowatt plus 1.3 megawatt hour. There is an example how to design the system or do the installations regarding the equipment. So, for example, if we want to use a system with 6 BC 107, which means about 600 kilowatt hour capacity, we need to use 3 KSC 50DP2 one smart meter. This type is dedicated for our installations, and one EMS01D because of the parallel work, and 3 separate AC disconnector feeder from the electrical switchboard to feed these 3 KSC 50DP2. And if we want to use 3 cabinets with 197D, we can use 6 KSC 50DP2 to double the charging and discharging capacity. In that case, we need to separate cabling the 6 inverter. This is the picture of the EMS01D on-grid system integrator equipment. It has an external mounting, which is possible, and the communication is over TCP per IP with the battery cabinets. The limitation is max 10 pieces with the new inverters, and the old ones has the 20 pieces maximum for the inverters. And in case we are using the old one, KSC 50DP, we can also use it in off-grid solutions, but in that case we need to add the system STS devices, which are standalone cabinets with a switchover device included and transformer inside included. And this is also makes possible the switchover in between 10 milliseconds to prevent the blackout. We have 2 types of this STS 100D and 250D, and this is the maximum kilowatt that can be connected to the devices because they have dedicated inputs regarding the inverters. So for the 100D, we can use 2 pieces of the KSC 50DP. In case of 250, we can use 5 pieces of 50DP. And in case of KSC 125, we can only use the bigger one and only 2 devices can be connected to it. This is the STS, how is it looks like. It's a standard cabinet with air condition and electronic device inside. It has the genset control and the standalone EMS included inside the door. And in case of usage of this, the other EMS in each cabinet will be the slaves, and these one will be the masters. And from the cloud we can operate this EMS remotely. We can see how to set up the system with STS 100. So it's in case we are using 100 kilowatt system, we can use the 2 KSC 50. We can parallel the 107 kilowatt hour capacity battery cabinets, 4 pieces of them, because each inverter can have 2 battery cabinets and 1 meter. And in that case, we do not need the EMS01D because the STS will solve this parallel communication. And next is the EMS that I want to show you. It's we have the emulator software here. So when we power on the device, we see this screen. We need to configure the first system. So I just briefly going through of that. We need to choose if we have STS or not. Let's say not. We need to select which there is the position. If there is an inverter in the equipment, it's a master. If there is no inverter on the equipment because it's the second of a parallel solution, it's a slave. We choose the master now. Is there an ATS available? We choose no. And we need to select the type of the cabinet capacity. Next, we can set here for example, the 197. And it is asking us, is there a cabinet next to it? You can see it's a single device now. And we need to choose the inverter type. Is it simple DP for on-grid solutions or DP2 with off-grid solutions? And we can give the numbers of these inverters. Okay, we need to choose if there is a diesel generator or not, and configure if there any KSTAR PV inverter on the site, because our KSTAR CNI string inverters can communicate in one system together with this CNI ESS solution. And lastly, we need to check where the meter is installed. This is necessary for most of the operation modes to install a grid side meter on the grid connection point of the system. Okay, and after we're done with these first settings, we can restart the equipment. When it's loaded, we can see the real-time flowings to the grid, to the battery from the KSC, or from the PV to the KSC, or to the load from the KSC. And this is the home button. So, and on the devices, we can check every device connected to the system. We see the PCS. If we click to the PCS, we can check the photovoltaics, the battery, which is connected to the system, the inverter AC side datas, and the grid diesel generator, and also the load. If we are going to the battery and click the battery, we can see the actual cell voltages, the SOC levels, and the temperatures by every cluster we added. And inside the battery box, we can check all the cells one by one. And this can be also read out by the Modbus protocol. If we go to the meter, we see the real-time data of the connected meter. And on the EMS, we see the versions. On the third page, we see the alarms, which are actual. For the troubleshooting purposes, this is the first page what we need to help you out. And we have the alarm log, what happened in the past, and what operation we done with this equipment. And we have the settings, which is mostly used in the commissioning. So we can set a lot of things here, which is the diesel generator startup SOC, for example, which is the off-grid depth of discharge, for example. There is many things to adjust here. And here we can set the running mode. We have 4 running modes supported by KSTAR. One is the manual control, mostly for third-party device controlling of the system and testing the system. Next is the self-consumption, and we have the time of use and the peak shifting. I show all the 4 later in a standalone sheet. And we have these system settings. We doing the serial number adjustment and all of the network settings, interface and servers. And lastly, we can upgrade the firmware on the last section. So briefly, this is the EMS screen, what we see on the site. So I jump back to the presentation. Okay. And the next level is the KMS data cloud. We have the monitoring system for the CNI battery cabinets. I will show it in later, the end of the presentation. And let's talk about the operation modes. Just restarting this. Okay. Okay, so the first the self-consumption is the most common, is prioritize on the site PV for the local loads. And after there is not that big load and there is a surplus PV, it can go directly to the batteries, storing the PV power during the day. And if there is no PV and there is a bigger consumption on the site, the battery cabinet starts to discharge itself for the loads. And next we have this peak shaving. We can optimize the energy by discharge and charging on grid in a peak or in the valley. In here we can set 2 thresholds. One is the upper threshold and one is the lower threshold. The upper threshold, if the power exceeds the upper threshold, it starts to discharge the battery cabinets, and if it's exceeds to the lower threshold, it starts to charge the battery cabinet. This is smoothing the curve of the grid power. And we have the time of use, where we can directly set the time periods when to charge or when to discharge the battery cabinets. This can be useful if the energy price are connected to this, and the system can adjust itself dynamically for the spot price controlling. And the last is the off-grid backup. which is working like the equipment are always has some kind of SOC level in any case, and this makes it possible that if there is the blackout, this capacity is always there to ensure the emergency power supply of the building. So these four operation modes are in our support, and it's programmed also in the cloud platform. So it's supported by us. This is the first level of the controlling, let's say, and this is the second level when we want to control our equipments with a third-party EMS device, and we just simply need to connect our third-party EMS controller to the bottom of our cabinet or to the EMS01D controlling box, and in that case we can read or write the registers of this EMS and giving commands in manual control mode when to discharge or when to charge and with what amount of power. If we are using the parallel solution, we can have the Ethernet switch supplied by customer and just telling the IPs to each standalone cabinets. On that picture, we can see a power curve of an installation. It's a STS system. There are different colors, meaning the different source of the power on the system. The purple one is the grid power. And if you see in the morning, the grid power is on, it means that they are pulling from the grid. When the sun is coming up, the PV starts to generate, and on the green line we see that the battery power is going to increase. That means that our battery is charging, and when the sun is going down, it's recognize it and starts smoothly discharge the battery cabinets because there is a continuous load on the household, so it starts to feed it. So we talk about the local EMS, the monitoring platform, and the third-party EMS, and we have this fourth level, which is the VPP partner integration of that controlling, which can be done by the third-party EMS, and it can make possible the spot price control, the supply-demand balance, and power market participation, and ancillary services, frequency control of our equipments to stabilize the grid. This is one example for the spot price control in Poland. We have the site where the prices are high, it starts to discharge, and when the prices are low, it starts to charge the cabinets, generating profit by discharging it in the correct time. The equipment should be charged to 100% every 2 or 3 weeks. It depends on the usage, and we need this because the calibration point is at 100%, and this 3.5 volt, this is the maximum cell voltage of each cell, and if we are reaching that 100%, it makes sure that our cells inside the battery are the same cell voltage, and this means that our system can be has a balanced charge and discharge for the full battery capacity. Regarding the warranty, we have 5 years of product warranty. We warranted, we will repair or replace the product or any part if there is a defective in manufacture or material for a period of 5 years from the date of purchase. And we have 2 years limited warranty of accessory products, including meter, air conditioning unit, and fire suppression system. And this starts from the following 2 dates: the date when the product was firstly installed, or 6 months from the date of delivery of the product. Regarding the battery cabinet, we have this 10-year performance warranty that we warrant that the battery system retains either 70% of usable energy for 10 years or minimum through output energy, which is 3.5 megawatt hour. That means that it's the maximum discharge power during the lifetime. And we ensure that the state of health is 70% at this level. The battery system should have complied with the operating condition under the specification and the installation manual supplied by us. And the starting dates are the same. And regarding this storage, if we are storing equipment in long term, we need to put it in an environment which is from -10 to 50. Okay, we have plans for 2026. We have the battery cabinet, liquid cooling, 60 kilowatt hour capacity. And these cabinets are liquid cooled. And we have the implementation of the new inverter for the home segment from 4 to 12 kilowatt, and the CNI segment to 80 to 100 kilowatt. And the next quarter is the 12 to 25 kilowatt inverter for the residential. And in Q3, 3 inverters dedicated PV farms, 690 volt. Without the PV, it can be used only these new inverters. This is one picture regarding the new version of the system configuration of the BC260. And for this, we can see mostly the same devices, but it has the liquid cooling unit inside and don't have the AC, the air conditioner device inside. Other features are the same. And I'm showing you some installation tips and limitation. So regarding our products, the inrush current is suppression technology limits the inrush current, which can make possible to attach big inductive motors on the site. And it has, when it is started in off-grid mode, it can solve the feeding of these big motors, because the inrush current is not making the equipment to stop the discharging if the power needs for the motors. The next is the phase independent control, which means that 100% of the nominal capacity of the inverter can go out to asymmetrical loads, but maximum 50% in one phase of the nominal capacity of the inverter. And we have the EV chargers also, which can coordinate and schedule the algorithm and maximize the system usage by dynamically controlling the EV charger and the battery cabinet together. We have some limitation in the wire distances. If we are putting two cabinets next to each other, it should be less than, the distance should be less than 5 meters. And regarding the meter, it's a simple RS485 communication between the master cabinet, which should be less than 100 meter. The next is the STS solution. If we are using the old cabinets with the STS shouldn't be shouldn't have more distance than 10 meters, because we have the special communication cables that we are giving to the equipments. So this 10 meter is necessary to keep if we are using STS. It's one thing to check. And we have the minimum distances for the planning the system. This is 1.2 meters from the bottom and the front. And from the right, we need to keep 100 millimeter for the handling of the inverter and checking the indicators there. And on the top, if we want a roof, we need to keep that 300 millimeters distance. I show some installation photos of the KSC50DP2. You can see the inverter is here. This is the cabinet itself. This is the front view of the inverter. We can see if we open the door, it has the EMS cover inside. We need to take out this cover to insert the SIM or connect the internet. And we can see the special cable glands here, which are IP protected. And there is a video when we open the door. We see the high voltage bulb, the switch device, the battery cabinets inside. This all together comes manufactured, and on the site, only the inverter needs to be attached. These are the battery connections, the communications, and the PV can be connected here. Okay, some pictures. These are the dedicated inputs of the KSC50DP2 inverter. So there is one for the grid, there is one for the backup load, and there is one for the diesel generator. I'm gonna show now the installation video. It's 8 minutes. So, let's start it. My question is that can you see my video?
Not yet.
Now? I started it. Okay, I will share then my other screen. 1 sec.
Maybe you will stop the presentation and share the other screen.
Yes, 1 sec. Okay. Maybe it's visible right now.
Yes.
Okay. There is a music in the background, so I will talk here. So we can see the connections on the bottom of the inverter. And we can see the grid, the generator, and the backup, and normal load inputs on the right side. the explosion venting panel, and other features of the equipment that shown. We can go through the packing list and the accessories list. The equipments, the new version also have the lifting eyes, so craning is possible also, but forklift is, if there is a good road to go closer the equipment or the foundation, it's the easier solution. We need to fix it. For this, we need to put the plates first, the holder plates, which comes with the inverter. It's communication of the meter. This is the auxiliary part of the cabinet, where the air conditioner works, the AC side of the equipment. We suggest to make the electrical switchboard like this. EV terminal crimping is necessary to go with a good quality device to make it smooth. Then we measure the PV voltage. It cannot be more than 100 or 850. And lastly, we install the meter and connect the communication by 2 wires to the cabinet. Current transformer that needs to be applied according to the nominal current of the lines. We have this rubber material that and last step is to make the holes solid. Okay, back to the presentation. Okay. So I'm gonna show now the monitoring. Okay, here we can see the monitoring page of the system. This is one STS site, for example. On the left, we can see the home page where we can see the flow charge, which is the actual producing of the PV power, the grid actual data. The battery is charging or discharging. Now it's charging with minus 2.8 kilowatts. The minus is always means the charging of the battery, and the plus is the discharging. And in that solution, there is a load power, which is 67.9. We can see the actual curve of a better day in January 19, a sunny day, where can we see the green, the blue one is the PV power and the green one is the battery power. The orange is the loads and the grid is the purple. The grid is always stays near the zero because of the zero export limitation that is set for this. And next we can see the main wiring diagram where is all of the equipments can be checked about the parameters, the real-time PV production, the SOC levels of the cabinets, and even the clusters of the battery cabinets. So the whole system drawing is visible online as green ones. Next is the operation strategy. We have this 5 operation strategy that I mentioned before. This system is in self-consumption mode, and we can set several things here, which is needed. Demand power, that means is the maximum power that can come from the AC grid connection point to the batteries. The maximum charging power, we can limit when to charge the batteries, and we can set if there another AC AC coupled inverter on that same bus bar. We can set the enable, and it makes it smoother operation together with KSTAR inverters. And many of the things we can set. For example, the SOC calibration, which is needed to sometimes calibrate the cell voltages of the battery cabinets. It depends on the usage of the battery cabinets. It's only necessary to set if it's not reaching the 100% state of charge regularly. We can see in the device monitoring when was this. So there was a sunny day. On the 19th, it's reached the 100%, but on next day it's only went to 32.1% maximum SOC. So if there is 20 days, for example, in a row that is like not reaching the 100%, the cell voltage can go unbalanced. We can see the STS device also on the AC side. What are the powers, and also the meter. We have 1 meter inside this STS and 1 meter at the grid connection point. We can make reports, energy statistics, push reports to email addresses if there is any alarm occurring. And we have the remote troubleshooting lines. For example, remote settings of each inverter 1 by 1 or battery cabinets. You can adjust the protection parameter or anything that is necessary to make the smooth working. And lastly, we can see here the main parameters of the site, which needs to be given during the first commissioning. Okay, and here is another site which is controlled by the third-party device. This, if we go to operation strategy, we see it's in manual mode. That means that the third-party device is reading and writing registers of the system. And if we go back for a better day, we can see that because in that site there are third-party PVs on the site, but therefore we do not see the PC power because it's only coupled on the AC side. So I just want to show that maybe at 6, we'll stop at 6. Yeah, here we can see better. Yes, this day. Yes, when there was a surplus PV on the AC side, it gave the command by start to charge the batteries by 50. So it's the losses, but it's always the surplus from the AC went to the battery itself. Okay,